Alright, hello everyone. In this video, we're going to be going over the check if heap educator problem from the Heaps module. So without further ado, let's get right into it. What we're supposed to do is write a program to test if a given array satisfies the constraints of a max heap and a min heap. Duplicate elements are allowed, and this will become important later. So we're given an isMin heap function, which is supposed to return a boolean. If it's a min heap, isMax heap function. If it's supposed to return, if it's a max heap, and heap play. Heap play is a little interesting. It's a special testing function we define that'll do different things depending on what type of data your array's in. So if it's a min heap, you're going to return the minimum element. If it's in a max heap, you're going to return the maximum element. If it's both a min heap and a max heap, we're going to return 0. And then finally, we're going to return -1 if it's neither of them. So we have a sample input. We have our sample output, 019. And the array represents max heap, thus the results are shown below. So this one is pretty straightforward. You basically just have to know your heap properties and everything else follows directly from it. So to start out, let's come up with an example heap. So I'm going to say, I'm going to put 8 up here. I'm going to put 7 here, 5 here. I'm going to say 4, 3, 1, 2. And we can verify that this is a max heap because every parent is bigger than both of its children. And we can see 7 is bigger than 4 and 3, 5 is bigger than 1 and 2, and 8 is bigger than both of those. And so that check we did right there, that is essentially what we're going to be doing in our code, right? So an important thing to remember is because we're giving our heap in an array form, we need to know what the array representation looks like. And that is pretty simply just the number left to right down each row. So in an array, this heap is going to look like 8, 7, 5, 4, 3, 1, 2. Now you may also remember this from class and discussion, but just in case, to find the index of a node's children, and for the purpose of this tutorial, we're going to use 0 indexing because that's generally what things are indexed with in C++. The numbers can be adjusted for 1 base indexing. We'll talk about that, but let's focus on 0 indexing. How would we find the index of each child of a heap element? So I'm going to remove these arrows so it's a little easier to see. But let's start with figuring out what the left child is. Well, let's see. The left child of 8 is 7, and that's at index 1. Okay, let's keep that in our mind right now. The right child of 8 is at 5, that's at index 2. So interesting thing to note already. The left and right child of a node are going to be adjacent to each other. So they're only going to be off by 1. That's important to know. Okay, so that was a pretty easy one because the children were the next two elements. But what about the children of 7 and 5? Because clearly 5 comes after 7, so its child can't be placed right next to it. Let's see. Okay, so let's look at 7. 7's children are 4 and 3. And so if we look, we'll see that 7's child is at index 3, and its right child is at index 4. Okay, I think I'm starting to see the pattern. But let's check one more time just to be sure. It looks like, yeah. Okay, and so finally, let's look at 5. 5's left child is at index 5, and its right child is at index 6. Okay, but 5 was at index 2. So let's think about all these numbers. Okay, well, it looks like for 7, that's just 1 above 8, and 5 is 2 above 8. So you could say, oh, it's just 1 plus the other index. But as we've seen before, that doesn't work for 7 and 5 because 7's child is at 3 and 5's left child is at 5. But if you examine it for a little bit longer, you see the formula emerge that for 0 indexed heaps, the left child is going to be at 2 times the index plus 1. And we can see 2 times 0 is 0 plus 1 is 1, 2 times 0. And then that follows that the right child is going to be at 2i plus 2 because it's always going to be adjacent. So 2 times 0 plus 2 is 2. And then this also works for the rest of our numbers. 1 times 2 is 2, plus 1 is 3, plus 2 is 4, and so on and so forth. Let's see. 4's left child, or no, 4 doesn't have a child, but 5's left child is going to be 2 times 2, which is 4, plus 1 is 5. And then the right child is going to be at 4 plus 2, which is 6. So we got all that. And now, what are the heap properties that we have to maintain? Well, for a max heap, the parent must be greater than its children. And in the case of this problem, since duplicate elements are allowed, it should be greater than or equal to its children. And that's the constraint for a max heap. And for a min heap, it's pretty similar. It's just the other way around. So the parent must be less than or equal to its children. Okay, so how can we implement this in our code? I think we can pretty easily get this done by just checking the children of, like going through the list and checking both children of each element. Now, when should we stop checking? Because clearly these last four elements, the second half of the list doesn't have any children. There's going to be nothing to check. And if we try to access those array elements, we're going to run into memory errors. Well, because it is a binary heap, we can pretty easily use a little optimization. So we're going to check from the 0th element all the way up to the size over 2 element. And what's that going to look like? Well, for this one, we have a size of 7. There's 7 elements. 7 over 2 is going to be equal to 3.5, but because we're doing integer division, that just comes out to 3. And so if we look here, we've got in element 0, 1, 2, and 3. And so we'll stop right before reaching the element index 3, because past that, past halfway in, past size over 2, all of our elements are going to be leaves. And so there's not going to be any children to check. So that being said, we can just jump straight in and define the code. This is really all of the conceptual stuff you need for this problem. Okay, so I'm pulling up my, my code, and let's get to work. Okay, so let's do a loop. Simple I loop for I equals 0. I is less than size over 2. And I++, let's see what we're going to do. Well, what is the opposite? We're trying to check. We want to return false if we run into any issue. And only if we make it through everything without running into some problem for the heap properties, then we want to return true. So what are we going to check that would immediately make this not a min heap? What we can do is just check the opposite of these properties. So because we want our max heap, the parent, to be bigger than children, we can check if the parent is less than either of the children. If that's true, we can return false right away. So we can just use our indices now. So if r at I is going to be, we're doing the min heap first. So if r at I is less than or is greater than either of its children, so at r of 2 times I plus 1, or r at I is greater than its right child, which is going to be at 2 times I plus 2, we are going to return false. So I'll format that real quick. Great. So we'll return false. And if we make it through everything in the list without returning false, we'll know that it must be a min heap and we can return true. And similarly, the is max heap is very much the same thing. We just need to change how we're checking it. So we can just do this, and then we can swap the greater thans to less thans to check the max heap priorities. Finally, heap play, the most complex part of this problem. Let's look at what's going on here. So let's see what we're supposed to do. If the array is a min heap, we must return the minimum element. If it's a max heap, we return the maximum element. We return 0 if it's both a min heap and a max heap, and we return 1 if it's neither. So that's pretty easy. Let's just define some booleans, because we're going to have to check if it's both. We're going to have to know the result of both. So let's define a boolean before anything to get the answers down. So let's have this up on the side for reference. Okay, let's see. Let's say bool, min, max. These booleans will represent our heap elements, and let's define min to be is min heap. We will pass in the array, and we will pass in size. And then we're going to say max is going to be the same thing, except we're going to do is max heap. We'll get that. We'll say r. We will say size. Great. And so these booleans are going to be what we can check with later. Now, we're supposed to return 0 if it's both a min and a max heap. So let's do that now, so we don't have to worry about it later. So if min and max, if it's both of these, then we want to return 0. If it's, here, move this over. Otherwise, if we have min or max, if it's either a min heap or a max heap, in both cases, based on the way that we define how our max heap looks, our minimum or maximum element is going to be at the very top. If we had a min heap, for example, if we had like 1, 2, 3, 4, 5, 6, 7, our minimum element is still going to be at element 0. So in both of these cases, if it's a min heap or a max heap, we can just return 0. Finally, if it's neither of these, we can return -1. And because we returned in the other control paths, we don't have to worry about else's. And that should be all the code you need for this. So let's bring this back over so it's visible. Let's copy everything. And then let us paste that into here. So let's see, paste here. We will run our code. Okay, our code successfully compiles. Now let us try submitting our code. Interesting. We failed some of the test cases. Why is that? So it looks like we're saying that we made a small error in the code. If it's a min heap or a max heap, we want to return the thing at index 0, not 0 itself. Now, if we submit this code, this should pass and give us the expected result. And there you go. This is how you check if an array is a heap.